Rigel. Rigel, designated Beta Orionis Latinized to Beta Orionis, abbreviated Beta Ori B Ori, is a blue supergiant star in the constellation of Orion, approximately 860 light-years 260 pc from Earth. Rigel is the brightest and most massive component and the eponym of a star system of at least 4 stars that appear as a single blue-white point of light to the naked eye. A star of spectral type Beta Ori, Rigel is calculated to be anywhere from 61,500 to 363,000 times as luminous as the Sun and 18 to 24 times as massive, depending on the method and assumptions used. Its radius is more than 70 times that of the Sun, and its surface temperature is 12,100 K due to its stellar wind. Rigel's mass loss is estimated to be 10 million times that of the Sun. With an estimated age of 7 to 9 million years, Rigel has exhausted its core hydrogen fuel, expanded, and cooled to become a supergiant. It is expected to end its life as a type Roman II supernova, leaving a neutron star or a black hole as a final remnant, depending on the initial mass of the star. Rigel varies slightly in brightness, its apparent magnitude ranging from 0.5 to 0.18. It is classified as an Alpha Cygni variable due to the amplitude and periodicity of its brightness variation, as well as its spectral type. Its intrinsic variability is caused by pulsations in its unstable atmosphere. Rigel is generally the 7th brightest star in the night sky and the brightest star in Orion, though it is occasionally outshone by Betelgeuse, which varies over a larger range. A triple star system is separated from Rigel by 9.5 arcseconds. It has an apparent magnitude of 6.7, making it 1/400th as bright as Rigel. 2 stars in the system can be seen by large telescopes, and the brighter of the two is a spectroscopic binary. These 3 stars are all blue-white main sequence stars, each 3 to 4 times as massive as the Sun. Rigel and the triple system orbit a common center of gravity with a period estimated to be 24,000 years. The inner stars of the triple system orbit each other every 10 days, and the outer star orbits the inner pair every 63 years. A much fainter star, separated from Rigel and the others by nearly an arc-minute, may be part of the same star system. Nomenclature. In 2016, the International Astronomical Union (IAU) included the name Rigel in the IAU Catalogue of Star Names. According to the IAU, this proper name applies only to the primary component of the Rigel system. In historical astronomical catalogues, the system is listed variously as H Roman II 33, S 668, B 555, or ADS 3823. For simplicity, Rigel's companions are referred to as Rigel B, C, and D. The IAU describes such names as useful nicknames that are unofficial. In modern comprehensive catalogues, the whole multiple star system is known as WDS 5145-812 or CCDM 5145-812. The designation of Rigel as Beta Orionis Latinized to Beta Orionis was made by Johann Bayer in 1603. The beta designation is commonly given to the second brightest star in each constellation, but Rigel is almost always brighter than Orionis Betelgeuse. Astronomer James B. Kaler has speculated that Rigel was designated by Bayer during a rare period, when it was outshone by the variable star Betelgeuse, resulting in the latter star being designated alpha and Rigel designated beta. Bayer did not strictly order the stars by brightness, instead grouping them by magnitude. Rigel and Betelgeuse were both considered to be of the first magnitude class, and in Orion the stars of each class are thought to have been ordered north to south. Rigel is included in the general catalogue of variable stars, but since it already has a Bayer designation, it has no separate variable star designation. Rigel has many other stellar designations taken from various catalogues, including the Flamsteed designation 19 Orionis 19 Ori, the Bright Star Catalogue entry HR 1713, and the Henry Draper Catalogue number HD 34085. These designations frequently appear in the scientific literature, but rarely in popular writing. Observation. Rigel is an intrinsic variable star with an apparent magnitude ranging from 0.5 to 0.18. It is typically the seventh brightest star in the celestial sphere, excluding the Sun, although occasionally fainter than Betelgeuse. It is fainter than Capella, which may also vary slightly in brightness. Rigel appears slightly blue-white and has a BV color index of 0.6. It contrasts strongly with reddish Betelgeuse, culminating every year at midnight on 12 December, and at 9:00 p.m. on 24 January. Rigel is visible on winter evenings in the northern hemisphere and on summer evenings in the southern hemisphere. In the southern hemisphere, Rigel is the first bright star of Orion visible as the constellation rises. Correspondingly, it is also the first star of Orion to set in most of the northern hemisphere. The star is a vertex of the winter hexagon, an asterism that includes Aldebaran, Capella, Pollux, Procyon, and Sirius. Rigel is a prominent equatorial navigation star, being easily located and readily visible in all the world's oceans. The exception is the area north of the 82nd parallel north. Spectroscopy. Rigel's spectral type is a defining point of the classification sequence for supergiants. The overall spectrum is typical for a late B-class star, with strong absorption lines of the hydrogen bomber series, as well as neutral helium lines, and some of heavier elements such as oxygen, calcium, and magnesium. The luminosity class for Beta stars is estimated from the strength and narrowness of the hydrogen spectral lines, and Rigel is assigned to the bright supergiant class Ia. Variations in the spectrum have resulted in the assignment of different classes to Rigel, such as Beta Ia, Beta Iab, and Beta Ie. As early as 1888, the heliocentric radial velocity of Rigel, as estimated from the Doppler shifts of its spectral lines, was seen to vary. This was confirmed and interpreted at the time as being due to a spectroscopic companion with a period of about 22 days. The radial velocity has since been measured to vary by about 10 km/s around a mean of 21.5 km/s. In 1933, the Hall line in Rigel's spectrum was seen to be unusually weak and shifted 0.1 nm towards shorter wavelengths, while there was a narrow emission spike about 1.5 nm to the long wavelength side of the main absorption line. This is now known as a P Cygni profile after a star that shows this feature strongly in its spectrum. It is associated with mass loss where there is simultaneously emission from a dense wind close to the star and absorption from circumstellar material expanding away from the star. The unusual Hall line profile is observed to vary unpredictably. Around a third of the time it is a normal absorption line. About a quarter of the time it is a double-peaked line, that is, an absorption line with an emission core or an emission line with an absorption core. About a quarter of the time it has a P Cygni profile. Most of the rest of the time the line has an inverse P Cygni profile, where the emission component is on the short wavelength side of the line. Rarely, there is a pure emission Hall line. The line profile changes are interpreted as variations in the quantity and velocity of material being expelled from the star. Occasional very high velocity outflows have been inferred, and more rarely in falling material. The overall picture is one of large looping structures arising from the photosphere and driven by magnetic fields. Variability. Rigel has been known to vary in brightness since at least 1930. The small amplitude of Rigel's brightness variation requires photoelectric or CCD photometry to be reliably detected. This brightness variation has no obvious period. Observations over 18 nights in 1984 showed variations at red, blue, and yellow wavelengths of up to 0.13 magnitudes on timescales of a few hours to several days, but again no clear period. Rigel's color index varies slightly, but this is not significantly correlated with its brightness variations. From analysis of Hipparcos satellite photometry, Rigel is identified as belonging to the Alpha Cygni class of variable stars. In those spectral types, the E indicates that it displays emission lines in its spectrum, while the P means it has an unspecified spectral peculiarity. Alpha Cygni type variables are generally considered to be irregular or have quasi-periods. Rigel was added to the General Catalogue of Variable Stars in the 74th name list of variable stars on the basis of the Hipparcos photometry, which showed variations with a photographic amplitude of 0.39 magnitudes and a possible period of 2.75 days. Rigel was observed with the Canadian MOST satellite for nearly 28 days in 2009. Millimagnitude variations were observed, and gradual changes in flux suggest the presence of long-period pulsation modes. Mass loss. From observations of the variable Ha spectral line, Rigel's mass loss rate due to stellar wind is estimated to be 1.5 plus 0.47 solar masses per year about 10 million times more than the mass loss rate from the Sun. More detailed optical and K-band infrared spectroscopic observations, together with VLTI interferometry, were taken from 2006 to 2010. Analysis of the Ha and HG line profiles and measurement of the regions producing the lines, loop and arm structures were also detected within the wind. Calculations of mass loss from the HG line give 9.4 plus 0. 9.7 m/ in 2006 7 and 7. 6 plus 1. 1.7 m/ in 2009 10. Calculations using the Ha line give lower results, around 1.5 m/s. The terminal wind velocity is 300 km/s. It is estimated that Rigel has lost about 3 solar masses m since beginning life as a star of 24 plus 3 m7 to 9 million years ago. Distance. Rigel's distance from the Sun is somewhat uncertain, different estimates being obtained by different methods. The 2007 Hipparcos new reduction of Rigel's parallax is 3.78 plus 0. Rho 34 mass, giving a distance of 863 light-years, 265 parsecs with a margin of error of about 9%. Rigel B, usually considered to be physically associated with Rigel, and at the same distance, has a Gaia data release 2 parallax of 2.9186 plus 0.761 mass, suggesting a distance around 1100 light-years, 340 parsecs. However, the measurements for this object may be unreliable. Indirect distance estimation methods have also been employed. For example, Rigel is believed to be in a region of nebulosity, its radiation illuminating several nearby clouds. Most notable of these is the 5-dag long IC 2118 Witch Head Nebula, located at an angular separation of 2.5 deg from the star, or a projected distance of 39 light-years 12 parsecs away. From measures of other nebula-embedded stars, IC 2118's distance is estimated to be 949 plus 7 light-years, 291 plus 2 parsecs. Rigel is an outlying member of the Orion O-Bone Association, which is located at a distance of up to 1600 light-years, 500 parsecs from Earth. It is a member of the loosely defined Taurus-Orion-Roan Association, somewhat closer, at 1200 light-years, 360 parsecs. Rigel is thought to be considerably closer than most of the members of Orion O-Bone and the Orion Nebula. Betelgeuse and Saiph lie at a similar distance to Rigel, although Betelgeuse is a runaway star with a complex history and might have originally formed in the main body of the association. Stellar system. The star system of which Rigel is a part has at least 4 components. Rigel, sometimes called Rigel to distinguish from the other components, has a visual companion, which is likely a close triple star system. A fainter star at a wider separation might be a 5th component of the Rigel system. William Herschel discovered Rigel to be a visual double star on 1 October 1781, cataloging it as star 33 in the second class of double stars in his Catalogue of Double Stars, usually abbreviated to H Roman 233, or as H233 in the Washington Double Star Catalogue. Friedrich Georg Wilhelm von Struve first measured the relative position of the companion in 1822, cataloging the visual pair as a 668. The secondary star is often referred to as Rigel B or Beta Orionis B. The angular separation of Rigel B from Rigel is 9.5 arcseconds to its south along position angle 204 deg. Although not particularly faint at visual magnitude 6.7, the overall difference in brightness from Rigel, about 6 magnitudes or 440 times fainter, makes it a challenging target for telescope apertures smaller than 15 cm6 At Rigel's estimated distance, Rigel B's projected separation from Rigel is over 2200 astronomical units O. Since its discovery, there has been no sign of orbital motion, although both stars share a similar common proper motion. The pair would have an estimated orbital period of 24,000 years. Gaia Data Release 2DR2 contains a somewhat unreliable parallax for Rigel B, placing it at about 1100 light-years 340 parsecs, further away than the Hipparcos distance for Rigel, but similar to the Taurus-Orion-Roan Association. There is no parallax for Rigel in Gaia DR2. The Gaia DR2 proper motions for Rigel B and the Hipparcos proper motions for Rigel are both small, although not quite the same. In 1871, Sherburne Wesley Burnham suspected Rigel B to be a binary system, and in 1878 he resolved it into 2 components. This visual companion is designated as component C Rigel C, with a measured separation from component B that varies from less than 0.1 to around 0.3. In 2009, speckle interferometry showed the 2 almost identical components separated by 0.124, with visual magnitudes of 7.5 and 7.6, respectively. Their estimated orbital period is 63 years. Burnham listed the Rigel multiple system as B555 in his double star catalogue, or BU555 in modern use. Component B is a double-line spectroscopic binary system, which shows 2 sets of spectral lines combined within its single stellar spectrum. Periodic changes observed in relative positions of these lines indicate an orbital period of 9.86 days. The 2 spectroscopic components Rigel BA and Rigel BB cannot be resolved in optical telescopes, but are known to both be hot stars of spectral type around B9. This spectroscopic binary, together with the close visual component Rigel C, is likely a physical triple star system, although Rigel C cannot be detected in the spectrum, which is inconsistent with its observed brightness. In 1878, Burnham found another possibly associated star of approximately 13th magnitude. He listed it as component D of B555, although it is unclear whether it is physically related or a coincidental alignment. Its 2017 separation from Rigel was 44.5, almost due north at a position angle of 1 deg. Gaia Dr2 finds it to be a 12th magnitude Sun-like star at approximately the same distance as Rigel. Likely a K-type main sequence star. This star would have an orbital period of around 250,000 years if it is part of the Rigel system. A spectroscopic companion to Rigel was reported on the basis of radial velocity variations, and its orbit was even calculated, but subsequent work suggests the star does not exist and that observed pulsations are intrinsic to Rigel itself. Physical characteristics. Rigel is a blue supergiant that has exhausted the hydrogen fuel in its core, expanded and cooled as it moved away from the main sequence across the upper part of the Hertzsprung-Russell diagram. When it was on the main sequence, its effective temperature would have been around 30,000 K. Rigel's complex variability at visual wavelengths is caused by stellar pulsations similar to those of Deneb. Further observations of radial velocity variations indicate that it simultaneously oscillates in at least 19 non-radial modes with periods ranging from about 1.2 to 74 days. Estimation of many physical characteristics of blue supergiant stars, including Rigel, is challenging due to their rarity and uncertainty about how far they are from the Sun. As such, their characteristics are mainly estimated from theoretical stellar evolution models. Its effective temperature can be estimated from the spectral type and color to be around 12,100 K. A mass of 21 plus 3 m at an age of 8 plus 1 million years has been estimated by comparing evolutionary tracks, while atmospheric modeling from the spectrum gives a mass of 24 plus 8 m. Although Rigel is often considered the most luminous star within 1,000 light-years of the Sun, its energy output is poorly known. Using the Hipparcos distance of 860 light-years (264 parsecs), the estimated relative luminosity for Rigel is about 120,000 times that of the Sun L, but another recently published distance of 1170 plus 130 light-years (360 plus 40 parsecs) suggests an even higher luminosity of 219,000 L. Other calculations based on theoretical stellar evolutionary models of Rigel's atmosphere give luminosities anywhere between 83,000 L and 363,000 L, while summing the spectral energy distribution from historical photometry with the Hipparcos distance suggests a luminosity as low as 61,515 plus 11,486 L. A 2018 study using the Navy Precision optical interferometer measured the angular diameter as 2,526 mass. After correcting for limb darkening, the angular diameter is found to be 2,606 plus 0.9 mass, yielding a radius of 74. 1 plus 6,173 r. An older measurement of the angular diameter gives 2,75 plus 0.1 mass, equivalent to a radius of 78. 9 are at 264 pc. These radii are calculated assuming the Hipparcos distance of 264 pc. Adopting a distance of 360 pc leads to a significantly larger size. Due to their closeness to each other and ambiguity of the spectrum, little is known about the intrinsic properties of the members of the Rigel BC triple system. All three stars seem to be near equally hot B-type main sequence stars that are 3 to 4 times as massive as the Sun. Evolution. Stellar evolution models suggest the pulsations of Rigel are powered by nuclear reactions in a hydrogen-burning shell that is at least partially non-convective. These pulsations are stronger and more numerous in stars that have evolved through a red supergiant phase and then increased in temperature to again become a blue supergiant. This is due to the decreased mass and increased levels of fusion products at the surface of the star. Rigel is likely to be fusing helium in its core, due to strong convection of helium produced in the core while Rigel was on the main sequence and in the hydrogen-burning shell. Since it became a supergiant, the fraction of helium at the surface has increased from 26.6% when the star formed to 32% now. The surface abundances of carbon, nitrogen, and oxygen seen in the spectrum are compatible with a post-red supergiant star only if its internal convection zones are modeled using non-homogeneous chemical conditions known as the Ledoux criteria. Rigel is expected to eventually end its stellar life as a type Roman II supernova. It is one of the closest known potential supernova progenitors to Earth and would be expected to have a maximum apparent magnitude of around 11, about the same brightness as a quarter moon, or around 300 times brighter than Venus ever gets. The supernova would leave behind either a black hole or a neutron star. Etymology and cultural significance. The earliest known recording of the name Rigel is in the Alphonsine tables of 1521. It is derived from the Arabic name Rail Jawza al-Yusra, the left leg foot of Jawza, i.e. rail meaning leg. Jawza was a proper name for Orion. An alternative Arabic name was Rjl al-Jabr Rail al-Jabar, the foot of the Great One, from which stems the rarely used variant names Aljabar or Eljabar. The Alphonsine tables saw its name split into Rigel and Aljabar, with the note at Disicher Aljabar. Nomenclature Etiam Rigel. Alternate spellings from the 17th century include Regel by Italian astronomer Giovanni Battista Riccioli, Riglon by German astronomer Wilhelm Schickard, and Rigel Algius or Algebar by English scholar Edmund Chilmeade. With the constellation representing the mythological Greek huntsman Orion, Rigel is his knee, or as its name suggests, foot, with the nearby star Beta Eridani marking Orion's footstool. Rigel is presumably the star known as Auvandil's toe in Norse mythology. In the Caribbean, Rigel represented the severed leg of the folkloric figure Trois, himself represented by the 3 stars of Orion's belt. The leg had been severed with a cutlass by the maiden bee High Sirius. The Lacandon people of southern Mexico knew it as Tunsil, little woodpecker. Rigel was known as Yeridit Kirk to the Wachibella Kori of southeastern Australia, and held to be the mother-in-law of Tatirgwil Altair. The distance between them signified the taboo preventing a man from approaching his mother-in-law. The indigenous Boron people of northwestern Victoria named Rigel as Kalogalorik Werpel. The Wardaman people of northern Australia know Rigel as the red kangaroo leader Unumbergu and chief conductor of ceremonies in a songline when Orion is high in the sky. Eridanus, the river, marks a line of stars in the sky leading to it, and the other stars of Orion are his ceremonial tools and entourage. Betelgeuse is Yajungan owl eyes flicking, watching the ceremonies. The Maori people of New Zealand named Rigel as Puanga, said to be a daughter of Rehua Antares, the chief of all stars. Its heliacal rising presages the appearance of Matariki the Pleiades in the dawn sky, marking the Maori New Year in late May or early June. The Maori people of the Chatham Islands, as well as some Maori groups in New Zealand, mark the start of their new year with Rigel rather than the Pleiades. Fuaka is a southern name variant used in the South Island. In Japan, the Minamoto or Genji clan chose Rigel and its white color as its symbol, calling the star Genji Boshi Yuan Shizing, while the Terra or Hake clan adopted Betelgeuse and its red color. The two powerful families fought the Genpei War. The stars were seen as facing off against each other and kept apart only by the three stars of Orion's belt. In modern culture, the MS Rigel was originally a Norwegian ship, built in Copenhagen in 1924. It was requisitioned by the Germans during World War II and sunk in 1944 while being used to transport prisoners of war. Two U.S. Navy ships have borne the name USS Rigel. The SSM-6 Rigel was a cruise missile program for the U.S. Navy that was cancelled in 1953 before reaching deployment. The Ritual Scaries are a chain of small islands in Antarctica, renamed after originally being called Utskura. They were given their current name as Rigel was used as an astrofix. Mount Rigel, elevation 1910 m 6,270 ft, is also in Antarctica. Due to its brightness and its recognizable name, Rigel is also a popular fixture in science fiction. Fictional depictions of Rigel can be found in Star Trek, The Hitchhiker's Guide to the Galaxy, and many more books, films, and games.